Chemical spills in the laboratory are serious events that can be hazardous to your health and to the environment. Keeping your lab uncluttered, properly transporting and storing chemicals, and careful planning of experiments can reduce your risk of having a chemical spill. However, it is still important that you and your laboratory are prepared for a hazardous chemical spill. In spite of your best efforts, spills happen. When they do, it makes sense to respond to them as carefully and efficiently as possible. The good news is that, for many laboratory spills, you may be able to safely clean them yourself. Not only does that save time, but your initiative demonstrates your accountability for maintaining a safe laboratory. Some spills can be cleaned up by the investigator, while others, due to their volume, location, and the hazardous nature of the chemicals involved, may require emergency assistance. Never attempt to clean up a spill that you feel may subject yourself or others to harm. It has been said that an ounce of prevention is worth a pound of cure, or, in other words, it is a lot easier to prevent a spill than it is to deal with the aggravation of paperwork required and cleanup of a spill. Therefore, employing preventive measures is a critical component of chemical spill procedures. Solvents should be stored in approved solvent cabinets or refrigerators. Never store solvents in hoods, floors, desks, or on benches. Solvent carrier containers should always be used to transport solvents to and from your laboratory. You should always try to use small quantities of solvents. Spill kits should be available for acids, bases, and any solvents on hand. Also, it is important to have proper personal protective equipment readily available. You have an emergency plan tailored for your lab that covers what to do if chemical spills occur in your lab. You should know where safety equipment is, and everyone in the laboratory should know who to contact and where their contact numbers are located in case a chemical spill occurs. You should review the emergency chemical spill plan for your laboratory with your laboratory instructor, professor, and fellow students as a group. The first thing that you should do if you have a spill is alert laboratory instructors, professors, and students in the immediate vicinity, and then you should ensure that you are not contaminated. Next, assess the size, chemical constituents, and location of the spill. Identify the material using personnel information, labels, or instrumentation. Identify the hazards involved using an MSDS or DOT information. If the spill is small, less than 4 liters, 1 gallon, there is no inhalation or significant fire or reactive hazard, the chemicals are not acutely toxic, and if you are not alone, you can put on chemical-resistant gloves, lab coat, and goggles, use absorbent in the spill kit to stop the spill from spreading, then use additional absorbent to soak up the spilled material. Remember not to use paper to mop up strong mineral acids and strong oxidizers, for example, nitric acid. Be sure to place contaminated cleanup materials in hazardous waste containers. If you have to hold your breath in order to clean up a chemical spill, you should not be cleaning it up. Do not just leave the spill to evaporate unattended. Place a sign on the door warning others of the hazards until the spill can be cleaned up. Get assistance by calling university police and the safety office. In the event that safety personnel are not at the scene of the spill, the university police officer will relay any specific information about the spilled substance through the dispatcher to the responding personnel. Upon receipt of the information, the chemical hygiene officer or other environmental health and instructional safety personnel will, if necessary, respond to the scene. You should review your chemical spill plan before you need it. The complexity and detail of a plan will, of course, depend upon the physical characteristics and volume of materials being handled, their potential toxicity, and the potential for releases to the environment. Review material safety data sheets, MSDSs, or other references for recommended spill cleanup methods and materials, and the need for personal protective equipment, for example, respirator, gloves, and protective clothing. Acquire sufficient quantities and types of appropriate spill control materials to contain any spills that can be reasonably anticipated. The need for equipment to disperse, collect, and contain spill control materials, for example brushes, scoops, and sealable containers, should also be reviewed. Acquire recommended personal protective equipment and training in its proper use. For example, if an air purifying respirator or self-contained breathing apparatus is needed, personnel must be trained in the requirement of the Respiratory Protection Program and attended annual training and fit testing. Place spill control materials and protective equipment in a readily accessible location within or immediately adjacent to the laboratory. Develop a spill response plan that includes names and telephone numbers of individuals to be contacted in the event of a spill, evacuation plans for the room or building as appropriate, instructions for containing the spilled material, including potential releases to the environment, for example, protect floor drains, inventory of spill control materials and personal protective equipment, method to contain spill materials, in most cases, as hazardous waste, including contaminated tools and clothing. Apply appropriate labels, hazardous waste and chemical description, until picked up. Decontamination of the area following the cleanup. Your instructor or professor should discuss your chemical spill response plan with everyone that will be in the laboratory. Your safety office is always available to help prepare your lab for possible spills. In the event of a chemical spill, the individual in charge of the lab is responsible for prompt and proper cleanup. It is also their responsibility to have spill control and personal protective equipment appropriate for the chemicals being handled readily available. And you must know where these items are located, and you must know where to quickly access appropriate contact information. Before starting any work with chemicals, you should verify that all necessary safety equipment and spill cleanup materials are available and in good working order. Additionally, you should ensure that the individuals who may be involved in spill response are properly trained in equipment use and spill cleanup procedures. Finally, you must regularly inspect all materials and equipment to ensure that they will function properly if you need them. The following are general guidelines to be followed for a chemical spill. More detailed procedures may be available in the Campus Chemical Hygiene Plan or Spill Response Plan. If there is a fire or medical attention is needed, contact University Police at 911. Attend to any people who may be contaminated. Contaminated clothing must be removed immediately, and the skin flushed with water for no less than 15 minutes. Clothing must be laundered before reuse. Use a safety shower if one is available. If a volatile flammable material is spilled, immediately warn everyone. Control sources of ignition, ventilate the area, and evacuate as necessary. Put on personal protective equipment, as appropriate to the hazards. Refer to the Material Safety Data Sheet, MSDS, or other references for information. Consider the need for respiratory protection. The use of a respirator or self-contained breathing apparatus requires specialized training and medical surveillance. Never enter a contaminated atmosphere without protection or use a respirator without training. If respiratory protection is used, be sure there is another person outside the spill area in communication in case of an emergency. Protect floor drains or other means for environmental release. Spill socks and absorbents may be placed around drains as needed. Contain and clean up the spill. Loose spill control materials should be distributed over the entire spill area, working from the outside, circling to the inside. This reduces the chance of splash or spread of the spilled chemical. Many neutralizers for acids or bases have a color change indicator to show when neutralization is complete. When spilled materials have been absorbed, use brush and scoop to place materials in an appropriate waste container. Polyethylene bags may be used for small spills. For most laboratory spills, 5-gallon pails are generally sufficient to hold spill material. For larger spills, a 15 or 20-gallon open-top drum with polyethylene liners may be appropriate for larger quantities. After placing sorbed material into the spill container, make sure you complete a hazardous waste sticker identifying the material as spill debris involving XYZ chemical, and affix the sticker onto the container. Spill control materials will be characterized by EHIS personnel to determine if they will be disposed as hazardous waste. Decontaminate the surface where the spill occurred using a mild detergent and water when appropriate. Your laboratory or work area should have access to sufficient quantity of absorbents or other types of materials to control any spill that can be reasonably anticipated. Remember, it is your responsibility to know where these spill control materials are located and to know how and when to use them. Personal protective equipment may include chemical splash goggles, gloves, nitrile or neoprene, polyethylene shoe covers, and splash-resistant plastic or Tyvek aprons and/or Tyvek suits. A polyethylene-coated Tyvek suit is made from lightweight material that yields little or no lint. It provides a barrier from minor chemical splashes, dust, asbestos, water, and other harmful substances or materials. Plus, it is disposable. No hassles or expense with laundering. Some absorption materials may include kitty litter, perlite, vermiculite, spill pads, spill boom, and other products, and DOT pails, 5-gallon, with polyethylene liners with minimum amount of loose absorbent in the bottom. Acid and caustic neutralizers are commercially available, such as Nutrisorb for acids and Nutricite 2 for bases. These absorbents have built-in color change to indicate complete neutralization. Sodium bicarbonate, solid or liquid, can also be used to neutralize spilled acids or bases. Commercial solvent neutralizers that are also available, such as Solusorb, act to reduce vapors and raise the flash point of the chemical mixture. Some cleanup tools may include a polypropylene scoop or dustpan, broom or brush with polypropylene bristles, polypropylene bags, sealing tape, pH test papers, and waste stickers. In any case, there should be a floor sign available that reads "Danger, chemical spill, keep away." The consequences of any spill of biological material can be minimized by performing all work on plastic-backed absorbent liner to absorb spills. A simple spill kit should be readily available and should include the following items: chlorine bleach or some other concentrated disinfectant, package or roll of paper towels, autoclavable bag, nitrile gloves, forceps for picking up broken glass. After cleaning up a spill, a simple write-up should be prepared to document what happened, why, what was done, and what was learned. Such documentation can be used to avoid similar instances in the future. Remember that major incidents are almost always preceded by numerous near misses. In the case of a major spill, you must assist in filling out your local Hazardous Material Incident Reporting System or form. Ask the Safety Office for assistance. Laboratories seeking to minimize and prevent spills should consider the possible results of their choices and procedures. Such consideration should focus on reducing the likelihood of spills as well as minimizing spill damage. Experimental plans should only involve chemicals that are actually needed for the desired results. Ideally, laboratories should only store chemicals that will be used within a reasonable period of time. Additionally, correct chemical and experimental equipment choices must be made. Finally, you must never settle for inappropriate laboratory arrangements. In this program, we have described procedures to help protect you from hazards associated with chemical and biological spills. There are a variety of procedures and protocols to follow when working with materials in your laboratory. In this safety program, we covered many aspects of chemical and biological spill procedures. We discussed who to contact, some hazards, flammability, personal protective equipment, general precautions, and training. We hope that you can use this information to stay safe and healthy in your learning environment. If you have any questions, contact your safety department.